The size of the scale factor, lesson 5. Let's look at the effects of different scale factors. Today's goals. I can describe the effect of a scale copy when I use a scale factor that is greater than 1, less than 1, or equal to 1. I can explain how the scale factor that takes figure A to its copy figure B is related to the scale factor that takes figure B to figure A. We've kind of talked about this already a little bit, but we're going to delve deeper. So make sure you have today's ICANS, today's date, and your page number, and you are ready to go. All right, so we're going to kind of skip forward here a little bit. We're not going to do all these activity cards. We're going to actually just focus on a few of them since we are not in a classroom to do this particular one. So I have 3 of the cards that we would have used if we were in the classroom. So taking a look at these, which of these has a scale factor of just 1? Yeah, it's this one, 8 here, right? Because if we look, we've got the same units being used to make each of the lines, the same distances for every part. So this one has exactly 1 for the ratio. This is a 1-to-1 ratio. What about the other 2? Well, one of them is a more than 1 and one is less than 1. Card 1 is a more than 1 scale factor because we're going from A to B, and because this is a larger version of A, we have to be using some sort of scale factor greater than 1 whole. Any part added to that 1 would make it bigger if we multiply it over. But in this case, it looks like we've got it about double, right? We got 6 across here, we got 3 here, we've got 4 for a height, we've got 2 for a height. So it's been doubled. Here, we know that this is less than 1 because we started off with 1 size. And then if we look at the figure that it makes in part B, we have something that's significantly less. In fact, if we look at the height piece on this, we can see that we have a height of 8 here and a height of 4 here. So this is less than 1 whole. In fact, it's going to be 1/2 because if we can make that one number in half to make this, the height from this, from the very top corner part down to the same height down here at the bottom part on that same height piece, then if that is half, then all these other lines end up having to be half since we know that it's supposed to be a copy. So the point is that you're making sure that you're looking at what the scale factor is. If it's anything more than 1, you're going to get something bigger than what you started with. If it's exactly 1, you're just going to get a duplicate. If it's less than 1, you're going to get something that's smaller. Let's look at a couple others here. So on card 2, the scale factor here is 3. So you're multiplying everything by 3 to go from A to B. So what would be the scale factor if you went from B to A? It'd be 1/3, wouldn't it? Because every one of these would be 1/3 the value. So if you to go from A to B, you have to take that 1 unit height times 3 to make this 3 unit height for B. How do you get rid of that if you're going to go back the other way? Well, then you have to multiply by 1/3, which is the same as, very similar to, in fact, the same thing as dividing by 3. And the reason why we want to think of it that way is when we talk about a scale factor, we're always thinking about it in a multiplication kind of fashion. Here, if the scale factor is 1/2 to go from A to B, what's the scale factor to go from B to A? Well, isn't it the same thing as what happened up in this previous part? It's the inverted fraction. It's going to be 2. So the scale factor here is 2. So the point of this is that when you go from a smaller to a larger, you're talking about a scale factor that's a whole number in some way. If it's the same, it's just 1. If you're going from a bigger to a smaller, then your scale factor has to be some sort of fraction or something less than 1 whole. All right, we're going to look at some more scale factoring here. Okay, we have the original here on the left and we have the copy on the right. What's the scale factor to go from the original to the copy? Well, let's see, I got 1 here. I've got 1, 2, 3, 4, 5 units here. 1, 2, 3, 4, 5. So what's the scale factor to go from the original to the copy? It's 1/5, isn't it? How do I know that? Well, I started off with 5 here. I have to multiply by something that when I get done with it, after I take 5 times it, it's going to give me just 1 whole. Well, if I take 5 times 1/5, then I'm going to end up with 5/5, which is the same as 1 whole. So here's another one. I've got an original at these measurements, and I'm going to make a copy. The copy has to be with a scale factor of 2. Is this going to be larger or smaller than what it is here? It's going to be larger, isn't it? Yeah, so the copy has to be larger because we had to double each of those lengths. Now, when I drew this out, I didn't draw those lines. I looked at the triangles. Oops. I looked at the triangles that made each of those lines to give me an idea. And using our scale factor of 2, I double the triangles, which if I double the outer parts of the triangle at the right triangle, then I know that the rest of it has to be doubled as well. Trickier one. So scale factor from the original to the copy is 3/2. So how do we go backwards? Well, to go from the original to the copy, we had to multiply by 3/2. To go to the copy, from the copy to the original, we have to multiply by 2/3. And why? Because our original, based on this, because 3/2 is greater than 1 whole, right? Because 2/2 would be 1 whole, 3/2 is greater than that. And so if that's what this makes, then our original has to be something that's smaller. And if we're going to have this as our unit for scaling, if we're going to go from the copy back to the original, we actually have to multiply every part by 2/3 to get back to that original smaller size. So if I take 3 here across the bottom, and it looks like all of those are 3, multiply by 2/3, I end up with 6/3 or 2. And you could have cross-canceled and got down to 2 anyway. But so every one of those lengths is now, any of the 3's are now 2. This was a total of 6. Yeah, going to be 4 now, right? And then again, the others end up being 2. So again, when you're talking about the scale factor, you have to think about which way you're going. If you're going from a smaller to a larger, you're going to have something that's greater than 1 whole. If you're going from something that's larger to a smaller, you have to do something that's less than 1 whole to make it work out. So if we talk about these two here, we can see that this is a copy of this original. What do we know? Well, a scale factor has to be something greater than 1 whole, right? What do we know about the angles? Yeah, the angles have to be the same. The angles don't change at all in the scale or in the scaled copies. If you think back to those previous ones we did, and you can rewind them if you want, we used the same measurement of the angle. It was just the lines that extended to make it. So what happened to the copy when we use a scale factor greater than 1? The copy ended up being greater than the original. What about when we use a scale factor that was less than 1? It became something smaller, right? And if it was exactly 1, yeah, it's just a straight up copy. It's going to be the exact same thing. How can we reverse the scaling to go back to the original figure when we have a scale copy? You do the opposite, right? So if you multiply by 5 to get the scaled copy, to go back to the original, you have to multiply by 1/5. You have to go with the opposite, with the inverted fraction to go back the opposite direction. Let's get some more fancier terms here. So when the scale factor is greater than 1, the scale copy is always larger. When it's less than 1, the scale copy is always smaller than the original. Exactly 1, it's the same size. Scaling can be reversed by using the reciprocal factors. Remember that reciprocal just means the opposite fraction. So in that one we did earlier, we did 3/2 to get to the copy. And then when we wanted to go back to the original, we had to use a reciprocal, which is 2/3. So that's what we do in every single one of these. If you multiply by 5 and 1, and you need to go back the opposite direction, you have to multiply by the reciprocal 1/5. How did I know that 5 and 1/5 is the reciprocal of it? Because remember, what do we know about all whole numbers? They have a 1 underneath them. We just don't write it typically. But we can when we're using fractions. And so then you can think of it as the opposite thing. You can also think of these as using what we have here over on the left and dividing to do that, because that's basically the same thing as reciprocal. But oftentimes it's going to be a lot easier, and oftentimes if you have a fraction already and you're going to do some sort of division with it, it's easier to multiply by the reciprocal as opposed to try to divide with the same thing. You always change it to that anyway. So that is all for today. Thanks for watching. Have a good one.